Okay, so this is the first of a series of short videos I hope to make on the smaller transistor curve tracer, and I have it next to an oscilloscope to point out a couple of differences. One is that this has a CRT for display. This has an LCD display. So this one cannot retain an image, but this one can. The other difference with an oscilloscope is the fact that along the x-axis on the oscilloscope is time, and so you're showing the way a voltage varies with time. On this thing, you're not. What you are plotting here is a current versus a voltage. So it's very much like the IV diagrams that I draw in class. And so in this case, for a transistor, what we are plotting is collector current versus collector to emitter voltage. So what that is if you take a look at this, chart here, what you see is a transistor right here, and the emitter is on top, the base here, and the collector is on the top, base and emitter at the bottom, and you can see that the emitter is tied to ground. Okay, so this is called a grounded emitter or common emitter configuration, and the current that we're talking about is collector to emitter. So it comes through and down like this, and so this would be the output, would be the current, and the input would be the current coming in on the base. So this is a slightly more complex version of the same kind of common emitter amplifier, and you'd say, well, gee, is this really common emitter? Look at this resistor between the emitter and ground. But in fact, this is an audio amplifier, and for audio frequencies, this capacitor has a very low impedance to the audio frequencies, and so the current comes down through the transistor and then through the capacitor to ground, and effectively this is a grounded emitter or common emitter configuration. So over here, what I have is the same thing that you're seeing on the display when I move it over here. Okay, so now you can see the display has something that's similar to what we see here. This is the collector current, like I said, and this is the emitter voltage, collector to emitter voltage, and that's what we have here is collector current and collector to emitter voltage. And so the thing that you can do is look at this. If you say, well, if you increase the collector to emitter voltage, the current goes up, but then it very quickly starts to saturate, where you get very little change in collector current, even though you crank up the emitter voltage a lot. You're in what's called saturation. And so these curves are for various amounts of base current going into the base. So if you pick a spot here and you go up here and you say, well, okay, I want to increase my base current by 100 to 200 microamps, that's a tenth of a milliamp. What do we get for change in collector current? We get something on the order of 15 milliamps. So the current gain in this transistor is 15 divided by 0.1, or about 150. Which is not unusual for transistors to have that kind of current gain, and it's what makes transistors so useful. It has the ability to amplify a signal, and that's why you have what is called here a common emitter amplifier. Okay, so basically that is that's what a transistor curve tracer looks like. I sort of apologize for the flashiness of it. My camera has only 15 frames per second, and so it's kind of slow, doesn't capture everything, but that's basically what you see is those same sets of curves.